Good afternoon, everyone. Sorry, I think today my topic is changed a bit. Rather than talking about the design assembly, I will more sharing about my journey about with the ROS. I am Reeve Chong from the Handplus Robotics. I hope everyone have a good lunch and will not be too sleepy after with my presentation. Today I will share about my journey with ROS. I start with ROS in 2013 when I first joined Taba Robotics Challenge. So during that time is also the time when the ROS is growing, rapidly growing up. Just some information about the ROS, about the Taba Robotics Challenge. So the seat of the address for the Taba Robotics Challenge DRC is trying to push the robotic industry using the ground robot, human robot, to perform a difficult task in disaster response operation. For example, to ask the human robot to go to the disaster environment to execute some of the complex tasks in a dangerous environment, such that remove the debris, drying the car, or cutting the wall, and doing the valve turning, and etc. During the competition, I was developed a multiple skill for the ROS robot. For example, on the top left, I am performing the wall cutting operation. So the difficulty here is that to keep the balancing for the human robot when perform those tasks, etc. So because the reaction of the wall cutting can easy to push down the robot, so it's important then to keep the balancing of the robot will not be fall down, at the same time to maintain the trajectory of a planning. And the bottom left is the task doing the valve turning. So the robot have to identify the where is the valve and then perform the task accordingly to turn off the valve during the in the disaster environment. The difficulty during this competition is like they have, even though it's a supervised control of the robot arm, but the network is like back off every 30 seconds, etc. to try to mimic the real environment in the disaster environment. On the right side is the robot perform the egg picking. So the egg is actually a raw egg. This demo is trying to showcase our capability when using the manipulation arm to do the combined force control. So the robot able to pick up the egg without cracking it, and at the same time is able to pick it up. And the top right is using human to do the picking project. After the DRC, I was continue my development in motion planning. I developed the system, automatic system in both. I think this is a old presentation site submit, but never mind. So one of the, in this video, I developed the system there to do the autonomous task picking. Pick up the, we developed the VI tag to identify, to help the robot have position itself to pick up the item. Actually, in this site, I have showing other video, such as I developed the gazebo environment. It's a one-to-one mimic the autonomous vehicle location to get the autonomous vehicle to the testing in the different environment. Because in our team, we always try to build up the whole simulation before deploy into actual robot. We believe that this can reduce the chance to broken the robot. At the same time, can get every team member have easy to develop their modules and integrate together. I will skip this as the other video is not showing here. Okay, in 2017, my team and I tried to join the Robotic Challenge, Amazon Robotic Challenge. We believe that competition is one of the way to help us push through our technology, because during the competition, we have to make our system reliability because we only have one chance. During the competition, if you miss it, then you are lost already. So the system have to go through the many try and error testing before the competition. At the same time, to complete the whole thing in a very limited time. So we believe that it can help a lot for us to pushing the team forward. On the left is doing the competition video. We are doing the stowing challenge. So we design the robot arm have a dual robot to speed up the whole performance. So the robot will go into the rip bin, pick up the item, and then place into the corresponding picking area. So after the storing, have to report a file to tell that what item have been storing. On the right side is on the other way. The robot is giving a file of a target task, like what to pick within the multiple item. So pick the corresponding item and then place into corresponding carton boxes. The difficulty in this challenge is that we only have around 3 months to build everything from the design hardware to the software, etc. So we're using AI to identify each of the item and then ask the robot to do the corresponding picking task. Okay, maybe I can go to the next slide. Okay. At the same time, when we are doing the competition, we also continue to do the research development in the hospitality environment. So here is so far of the task scenario that we are doing the robot picking. So in the top left is to mimic the pharmacy environment when the order giving the medicine to the patient. So he will key in the information to the system, and the robot will get the item from the mimic. This one is a mimic demo. The real demo in the Chong hospital will be the same. And then pick up the item, place into corresponding plastic bag. Inside the plastic bag, or will print the patient information, especially how many times should be taking the medicine, etc. On the right side is the random picking. So every day, the hospital have to prepare a lot of different size of running for the male and female to support to each ward. So the robot will do the preparation into the trolley, and then the trolley will be sent by the AMR to each of the ward. And the bottom left is the surgical tool quality check. After the picking, we'll do the identify what is the item, and is it item have any broken, etc. So thanks for the support by the NRP, we're able to make this development into the next step to do our commercialize. Okay. In 2018, we started our company, and also we bring forward our technology from fixed picking to a mobile picker. So we participate in a different competition to try to enhance our skill. So we participate in ROS 2018 manipulation in Spain, DHL Robotic Challenge in Germany, and also the JDC in China as well. So the key is to put our picking technology into the mobile, and then get the mobile robot to do the picking tasks. On the top right, we only have around 1 week to implement all our software into the robot developed by the Power Robotic. So we are in Spain for 1 week to bring in our train the AI to identify the item, and also include the task planning to get the robot ready to do picking. And the left side, we also have 2 weeks time to convert the previous robot into this new robot to targeting to picking up the Dell box. It's up to 5 kg and perform the corresponding task. So at the same year, we incorporate the Handplus Robotic to try to serve the industry better, so that we have better support to the industry. In 2019, we launching a OnePlus software, which is built on top of the ROS. The key here is make the interface easy for the the engineer or even technician to deploy the system on the field. So in our OnePlus software have included all the technology we've been participating in the competition and tested out, such as 2D vision, 3D post estimation, task planning and error accuracy, and also the motion planning as well. So our idea is not everyone can do the terminal programming. Even though some of us, like developer, we like to do the terminal programming, but not everyone able to do the programming. So we think that easier to use user interface is a key to them. So we build out a controller, have all our technology inside, and do the technician or even the engineer can just go to the on-site, set up the parameter, then the whole system can be turned out. From the OnePlus software, we have deployed multiple robots on the field. From the top left is the one we deployed in China, which is used for the e-commerce environment. So the robot will, based on the EMS system, to assign what to pick up and how many items to be picked up, pick from the bin, and then do the place it into a packing machine. The packing machine will based on the order and for to label up the information like the address and etc. And then it's straight away collect by the postman. And the bottom left is the one we are doing palletizing. So the all the system is using vision. So the robot will use the camera to identify the box size and then do the palletizing. And the middle one is sorting. So we using the camera to do a demonstration of sorting different items. And the whole system is running, the vision is running by the AI. The bottom is similar, but it's a differentiate between the mobile picker and the AGV and work together with the robot arm. So the robot arm will pick up the item and they ask the AMR to come and pick up. We also deploy into different industries such as the agriculture one. So the robot arm can easy to set up to do the performance like pick up the pot of the vegetable, etc. And then even pick up the seed to put inside into the pot as well. Okay. In 2019, during the COVID time, we want to contribute back to the public as well. So we have collaborated with the NTU to develop our XT board. The robot can be used for supervised control, get the robot to do the disinfection in a different environment, such as hospital or canteen. The idea is to lower down the chance for the nurse or operator or cleaner in the environment to get affected by the COVID. So the robot can do the scanning of the environment and then do the spray accordingly. So the whole system built up in this demo robot is within 3 weeks, include fabrication and design and also the software as well. In 2020, last year, we are trying to deploy we continue to deploy our system with using the OnePlus software in a different industry. So for example, on the top left one, we are deployed like 4 machines for a finished product QC. So the robot will do the QC in the 6 dimension, and then the robot arm will pick up and do the packing. So it have helped the industry to reduce a lot of their manpower. And to build this using our OnePlus software, the development time have increased a lot in our company. On the right side is a mobile picker used inside a logistic company. So the robot someone can be ordered through the touchscreen, for example, to mimic like the e-commerce in the logistic company, order, and then the robot will go to the shelf and then pick up the corresponding item and then deliver back the whole tray to the operator. And on the very right side is one of the challenge project we did before. is I try to replace the tree pruning in the environment in the Singapore. So we put a robot arm and even cutter onto a rolling boom so that it can be go up to like 10-meter height to perform the tree pruning. On the bottom left, last but not least, this one is last year when we deployed a robot system for the army to do the goodie pack picking. So all the 6 robots have work together with the human to do the packing of the goodie bag. And this robot, yes, right now how much time we do the integration on the site when all the hardware is ready, it's only take us for 3 days. So the whole system include the integration of the wiring system, etc. Because of the OnePlus help, we can push it only using 3 days to deploy all 6 robots together. And on the bottom 2 video is Assista Cafe. We help the Mitsubishi to deploy the system. So I believe that if you want to see the actual in the movement, I think Mitsubishi would not mind to have show you guys. So this robot is do the picking to get the coffee and then deliver to the different meeting room for their exhibition area. I think I go a bit fast. That's all for my presentation. Hold on. Yeah. So please let me know if you have any question.
Okay. Thank you, Reeve. Let's give him a round of applause. All right. We will now open the floor for questions. Does anyone have any questions?
Okay, no problem.
Hi, thank you for the great presentation. Amazing work that you've done over the years. I'm Jim from ARTC. I have a question basically. So I've seen that you've used different brands of robots to do your work, right? Like including for industrial robot manipulator arms, right? So can you have generic system architecture or generic platform, let's say for one application, where you can interchange different brands of robots for the arms? Or is your systems locked in or to a proprietary brand? Like for each project you have to work with that brand's tools and programming language? Thank you.
Thank you for your question. Actually, our company can use all the different brand of the arm. And thanks for the ROS, actually, most of the robot manufacturers now have the ROS driver support. So in our system, we create a generic motion planning and vision picking system. So each of them have, through our interface, talk to different robot driver, and which, because of the ROS, have a standardized communication nowadays. So it's easy for us to pick and plug with a different arm. That's why all the application, we can switch the arm within, let's say, 15, 20 minutes.
Thank you for the question. Does anyone have any other questions? Okay, if there are no further questions, then we've come to the end of the Q&A session. Thank you, Reeve. Let's once again give him a round of applause.